Knowing that air is matter because it has mass, it takes up space, it has volume, it feels the effects of gravity, giving it weight, okay, we can kind of measure how much air there is in a location by measuring the air's pressure. And there's other different, there's a tool that we use to measure the air pressure. Remember guys, air pressure is the amount of air packed in a certain area which allows it to squeeze. So the higher the air pressure is, the more compact the air is, and so it squeezes harder. The more spread out the air is, the lower the pressure because there's not as much air in that location to squeeze against things and press against things. So when understanding weather, it's important to keep an eye on the air pressure because when air particles spread out and pressure goes lower, you're opening up room in the air for other things that we don't want to get in it. Things that we don't want include water vapor. We know that when water vapor is in the air, we get yucky things like humidity and precipitation, fog, clouds. All those things are results of water vapor being included in the air. Okay? Without water vapor, air is packed with stuff that makes the weather nice. So high pressure air, when the air is packed with just air, there's very little water vapor that gets in and it makes our weather better. When air pressure is low because it's spread out, well, that's not the best weather because too much bad stuff can get in. There's too much room available for other things like water vapor to get in and ruin the weather. So we keep an eye on air pressure. We do it with tools like this called a barometer. Okay, this barometer has a little hollow disc inside this machine that is sensitive to how hard air presses on it. The more the air presses on it, the bigger the number reads. The more gently that the air presses on it, the lower the number is. Okay, so for better weather, you want high numbers on this kind of barometer called an aneroid barometer. To show you the logic of how that works, I'm going to construct a really terrible model of a mercury barometer, okay, which involves liquid. So I have blue food coloring water in this plastic tube. I put little bits of clay to make like a tripod foot. I'm going to put a glass bowl on top and I'm going to invert this entire apparatus. Wish me luck. Okay, now what you see here, you guys, is you see a little bit of the liquid sitting in the bowl and a little bit of it sitting inside the tube in the middle. Now, this is an indicator of the pressure of the air. The higher the air pressure in this room is, the harder that air is going to press on the liquid inside the bowl. Now, when the air pressure presses on the liquid in the bowl, the liquid has no place to go except possibly up this chamber, this tube. When the air pressure is weaker, okay, it's not going to press on the water in this bowl as much, which is going to allow the water level in the bowl to rise. And as the water level in the bowl rises, the water level inside the tube will sink. So basically, what you need to understand is the higher the air pressure is, the higher the water inside the tube is going to go. The lower the air pressure is, the lower the water inside the tube is going to go. It's an easy thing to understand. Higher level of liquid, higher air pressure. Lower the level of liquid, lower the air pressure. Why does it do that? Because higher air presses on the exposed liquid in the bowl. It's like that game you saw in your notes where you hit the hammer onto the pad to make the bell ring, ding, right? The harder you press with the hammer, the higher up the piece of metal that rings the bell goes. So the higher the air presses here, the higher up the water inside the liquid goes. The wimpier you hit it with a hammer, like when I go to the carnival, and I never get the prize, okay? I know I look ripped and muscular, but don't let that fool you. I can't swing a hammer very well. So that's an example of lower air pressure where we're not hitting this water or this liquid hard enough to make the water inside the tube go up high. So we use these kinds of devices to tell if weather's going to be good or bad. The higher the air pressure, we know we're in for good weather. We see that air pressure start to decrease and get lower, that means that bad weather is on the way.